Hello everyone, welcome back to our channel. Today we are back with one more interesting problem, that is the problem of the day of Leetcode. Problem number is 2467 and the name of the problem is the most profitable path in a tree. Okay, so let's start with the problem, discussing the problem. So we are having, let's read the problem statement first. So we have been given there is an undirected tree with n nodes labeled from 0 to n minus 1 rooted at node 0. We are given a 2D integer array edges of length n minus 1 where edges of I is equal to a of I comma b of I indicates that there is an edge between nodes ai and bi in the tree. At every node I there is a gate. You are also given an array of even integers amount where amount of I represents the price needed to open the gate at node I, and if the amount of I is negative, or the cash reward obtained of opening the gate at node I. Otherwise the game goes on as follows. Okay, so I know most of you will not get the problem in one go, so I have simplified the problem statement so that you can understand it in a much simpler manner. So let's see. So we have been given a undirected tree with n nodes labeled from 0 to n minus 1. Okay, and Alice starts at node 0 and Bob starts at given node Bob. Okay, both moves towards their destinations. Okay, and Alice moves towards a leaf node, that is any valid path, and Bob moves towards node 0. Okay, and each node has a gate with a certain cost, that is negative value, or a reward, that is positive value, to open it. Now the twist is basically if the Alice and Bob reaches the same node at the same time, they will split the cost reward. Okay, and our goal is to maximize the Alice net income and as she moves towards an optimal leaf node. So let's see through the example, and do not worry with the problem statement. I will explain you again with much more simpler manner. So first of all, let's go through the example. We have example edge. We have been given an edges list of lists, that is 0, 1, 1, 2, 1, 3, 3, 4, and Bob is equals to 3, and amount is equals to minus 2, 4, 2, minus 4, 6. So what it is depicting here is basically Alice start at node 0, that is root, and Bob starts at node 3. Here it is given 3. So Bob starts at node 3. So let's see how they will move basically. So Alice is at 0. So she pays minus 2. And both Alice and Bob meet at node 1. They will split 4. Each gets plus 2. Okay. And Alice moves to node 3. But Bob has already opened it, so no change. And Bob reaches to node 0 and stops. Alice moves to node 4. So he will gain plus 6. So the total profit will become 6. That will be the final answer. So maybe you guys get confused in the cost splitting and everything. So I will explain what here it is going on. So we have a tree, basically a type of graph where there are no loops, that is acyclic. And there are two players for this game, that is Alice and Bob. And what they are doing is Bob always moves towards node 0 step by step, and Alice can move in any direction to collect the most money out of it. Okay, so each node has an amount of money that Alice can collect. Okay, so and if Alice reaches a node before Bob, she takes full money from that node, and if Alice and Bob reaches a node at the same time, Alice gets only half the money, that is the amount reward is shared between the two. And if Bob reaches a node before Alice, she gets nothing from that node. Alice's goal is to collect the maximum amount of money possible by choosing the best path. So what we need to do is basically we need to track the Bob's path and record when he reaches each node. Okay, so we will simply use depth first search here for Alice to find the best route that gives her the most money, and we will return the maximum money Alice can collect. this is the problem state, as problem is asking for us to return the maximum money Alice can collect. Okay, so let's see the what can be the brute force approach for this. Okay, what we can do is basically in the brute force we will not go in deep because the problem is quite big, so we will be giving more focus to optimal solution. But yeah, we will discuss the logic of brute force. So what we can do is basically we can simulate all the possible path Alice can take to any leaf node. Like we can check all the possible possibilities and all the possible routes. So we can calculate Alice profit for each path and we can return the maximum profit possible. But this process is quite inefficient. Like for exploring all the paths will lead to an exponential complexity, that is 2 to the power n. So since n can be 10 to the power 5, this approach is too slow to follow. So we need something better and optimized. Okay. So let's discuss and go towards the more optimal approach here. Okay, how we can think of it. Let's discuss this basically with the dry run and example considering it. Okay, so the problem involves a tree that is undirected and acyclic, connected acyclic graph. So which does not contain any loop. The key challenge is to maximize Alice's net income while considering Bob's movement. Okay, so if we need to consider Bob's movement, so we need to track also the Bob's movement. So let's see. So Bob's always moves towards node 0, which means we can track when Bob reaches each node. And Alice can choose any path towards a leaf node to maximize its profit. Okay. And when Alice and Bob reaches a node simultaneously, the amount is split in half. That is, the reward is shared. Okay. So strategy is basically building an adjacency list from the given edges to represent the tree. Okay. So finding the Bob's path from Bob to 0 and track when Bob reaches each node. We will use DFS, that is depth first search, for Alice to explore all possible paths to maximize her profit. And if Alice reaches before Bob, she will take the entire amount. And if Alice and Bob reach at the same time, the amount gets shared between the two. And we need to return the maximum profit from all the possible paths. Okay. So we have discussed the approach we have to follow. Now I have done is basically I have break down the code in several parts so that I can explain it to you guys in a very simple manner. So step 1, what we need to do is basically we will build the graph. We will construct an adjacency list from the given edges. So that is easy, quite. Like we will use vector int graph and we will traverse and we will push back the edges. That is here it is given graph edge of 0 dot push back edge 1 and graph edge 1 dot push back edge 0. Since the input tree is undirected, we will store edges bidirectionally. Okay. So now let's see the step 2, what we have to do. In the step 1 we created the graph, we basically with the help of adjacency list. So next step is finding Bob's path to node 0. This is given in the question, like Bob always moves towards node 0. Okay, so we need to track the time Bob reaches each node. So basically what we need to do, we have to store the Bob's arrival time at each node. It is quite important here. So we will be storing it by using vector int Bob path n comma -1 and temporary list to store Bob's path. Basically vector int path will be the temporary list. Then again we will use like we have to fill the Bob path. We will use bool function for fill Bob path. Okay, and we will use the if condition here. If the node equal to 0, then Bob reached node 0. It's quite obvious. Then after that we will use for loop for neighbor and graph node. So basically why we are using it, like for considering it, we don't get back to the parent node, so we are putting the condition here if neighbor is not equals to parent, path pushback node, basically for avoiding of the fact that we should not go back to the parent node. Okay, And again we will put the if condition for if Bob reaches 0, we will return true, because we have to track that only. Okay, so otherwise if both the conditions are not true, we will return false. It's simple. And this is the function we use, fill Bob path. We need to start from Bob's initial position, and this is the recursive function basically, which traces the Bob's path from Bob to 0. The Bob path array stores a timestamp basically at which Bob reaches each node. Basically, here we have initiated this Bob path. It stores the arrival time. Okay, so now Bob path of I is equals to t means Bob reaches node I at time t. It's as simple. We are not doing anything extraordinary. Now for Alice we need to run the DFS for exploring all the possibilities. So Alice start from 0 and explores all possible paths. If Alice at each node, if Alice arrive before B, Alice will take all the amount. And if Alice and Bob arrive simultaneously, they will take half the amount, and basically they will split. And if it's a leaf node, so we need to return the max profit. Otherwise we will continue DFS to find the maximum profit path. Okay, so for this for DFS we will create a function that will take inputs, that is get Alice max score, and it will take node, parent and current score and timestamp as input. So we can break it into two cases basically, if the Alice reaches before Bob, or if the Alice and Bob reaches at the same time. So if the condition is first, that is if Alice reaches before Bob, that means Alice will take the whole amount, and we will increment the current score plus is equals to amount of node, that will whole amount the Alice will get. And in case 2, if Alice and Bob reaches at the same time, the amount gets shared. So basically a current score will be divided into amount node will be divided into half, so they will both get, the amount will get split. And if it's a leaf node, we will return the profit, basically current score, that will return the current score of game. And at last we will explore all the possible paths for Alice, that is by using for loop we will iterate it, and we will use the max score variable, and we will take the max of max score, or get Alice max score. This will give us the max score. And since we need to get the maximum profitable path, so we will explore all the path and we will return the max path. So for returning max path, we are doing max score here, and we are comparing it with max score and get Alice max score function. Okay, and after that we will return max, and at last we will return get Alice max score. This DFS recursively explore all the paths for Alice. We will keep track of time and profit, that is current score. The base case occurs when Alice reaches a leaf node. That means at that time we need to at that point the profit should be returned, and the maximum profit from all paths is returned. So this problem is quite simple, and let's try run this with an example. So we are having input edges given here, and Bob is equals to 3, that is Bob will start from 3, and amount is given here. So tree representation you all can see here, basically Bob starts at 3 and move towards 0. So Bob is here at 3 and he will move towards 0. So path 3 to 1 basically it will give 0, and Bob reaches 3 at time is equals to 0 to time is equals to 1 and 0, then t is equals to 2, that is he is here right now 3, then 3 to 1 he will take t is equals to 1, and then from t 1 to 0 it will take -2, that is this. And Alice best path is Alice at 0, amount is equals to -2, that is given here, and Alice moves to 1. Alice and Bob reach simultaneously, so amount will get shared, that is 4 divided by 2 is equals to 2, and total that will be there -2 plus 2 is equals to 0. Okay, Alice moves to 3. Bob already opened this gate, so Alice gains nothing because Bob started from here. And total is equals to 0. So Alice straight away moves to 4. So full amount will be plus 6. So the total will be 0 plus 6 is equals to 6. So final answer will be 6. Okay, it is simple question, but yeah, the question is quite simple, but getting through the exact what we have to do, basically the requirement of the question, if you get the requirement, the question is as simple as you can think. Simple DFS we have to use for exploring all the possibilities of Alice, and for tracking Bob we need to use the adjacency list. So basically graph representation we did, adjacency list, and Bob's path calculation DFS, and Alice profit calculation is for in that also we use DFS, depth first search. So the efficient, this is the quite efficient solution we can think of. Let's see the complexity. So the time complexity will be like O of n, and building the graph will be O of n, finding Bob's path will be O of n, as simple because we are not doing anything extra. Running DFS for Alice will be O of n. Total complexity will be O of n, as each node is processed once only. Space complexity is also O of n. We are not using extra space than the adjacency list. And graph storage is also O of n. Recursive DFS call is stack O of n because we are taking the function here that will return the maximum profit. And additional arrays we use, that is Bob path and path, that will take O of n. And total space is also O of n. I hope the solution is clear to all of you. Kindly go through the let's go through the code once to show you all. Basically this I have explained everything in detail by breaking it.